So before we start talking about the properties of relations and the things you can do with them, we need one more definition, and it's the definition of the inverse of a relation. This is exactly what you would expect it to be based on the conversation we've already had about the inverse of a function. And so if we start off with a relation from A to B, then the inverse is also a relation. It's going to go from B to A. We're going to write that R with a -1 and a superscript, just like we did for functions. And this inverse relation is defined, again, as I said, exactly the way you would expect it to be. If xy is an element of the original relation, then y comma x is a member of the inverse relation. So I've got an example here, right? This is a relation from a set to itself, right? So if we call these sets A, you see they are identical. And there is a special way we'll say this sometimes. Normally we talk about a relation from A to B, or we'll say this should be a capital, right? From A to B. When we're talking about a relation from a set to itself, we'll sometimes just shortcut this a little, and we'll say a relation on A. If there's only one set mentioned in the name, then it's you can infer that it's going from that set to itself. All right, so I have a relation here, right? And you can see this is kind of what this is doing is it's taking every element to the next element. So A goes to B, B goes to C, and then when we get to the end, we loop back to the beginning. All right, so I've got this is our original relation. So this is the relation R. So my question here is just what is our inverse? Right? Well, our inverse, let me put that up here. Right? We'll do our inverse up here. We'll just do it with the arrows going the other way. And the arrows literally just reverse. So now it's taking every element of A to the element that came before it alphabetically. And again, when we get to the end, we just loop back around. Right? So that would be the inverse of the original relation R. So I have another example here, and this one is should be familiar to you, right? We've got this equation y equals x squared, and I'm just taking that very hopefully familiar parabolic equation, and I'm just kind of phrasing this in terms of our new concept, right, in terms of relations. So what I'm doing here is I'm going to use that to define a relation from R to itself. And the way I'm going to do this is x is related to y if and only if y is equal to x squared. Right, so let's see some points on the relation here just to kind of get a feel for this. It is what you're familiar with. What this is saying is that if I pick an x value, right, the corresponding y value is that number squared. And the graph of that obviously is this parabola that you've hopefully seen many times before. So how can we define the inverse of this? All right, well, the inverse, we just go the other way. Right? Again, very similar to what you've seen before. Now we're going to, if we pick a y value up here, the point in the inverse that gets paired with it is the corresponding x value. So here I would say, right, the point, and you got to think about the order now, right? I would say the point 4, 2 is in the inverse of the relation. And that makes sense, right? Hopefully, because remember what our definition said, right? Our definition said 4, 2 is in the inverse if and only if 2, 4 is in the original relation, and 2, 4 is. right? Because 2 squared is equal to 4. All right, now there is another point though, right? I mean, I could have gone the other way. I could have taken this 4 and gone over this way and ended up down here on -2. And remember, that would have been fine. With relations, we do not have that requirement that each x value goes to 1 and only one y value. So I would absolutely also say that 4 comma 2 is in the inverse, excuse me, 4 comma -2 is in the inverse. And again, this does match our definition because -2 comma 4 is in the original relation. Right? So that's what we mean by an inverse, right? An inverse just takes all of the values from the original relation, right, all the ordered pairs, and reverses their order. Okay, so now we've got a bunch of definitions in our toolbox to work with. In the next series of lectures in this topic, we're going to look at some properties of relations, right? And then from there, we're going to go on and look at some of the things that we can do with them.